Okay? So let's look at your roller coaster right here, and we need to find the vertex of the roller coaster. It should be somewhere up here. I'm going to wait a minute to see what suggestions you guys have for the vertex of the roller coaster. If you have this open in Desmos, you can look at the Desmos to find the vertex as well. All right. I'm switching over to the Desmos so you guys can help me find the vertex. It looks like the x value is negative. What number should we try for that? Should I try -2, -3, -1? I'm trying to give the point for the vertex. Yeah. So 0, 0 is the vertex of this parabola, but I'm talking about the roller coaster. So what is the vertex of the roller coaster, guys? Give me something to try. Just try. Oh, -5? Or I need 2 numbers. So, I know what you're thinking. You're thinking of the equation. We haven't gotten to the equation yet. So I have the 0.55 here. I need a point. Okay, so here's -2.5. Guys, we're getting closer. It needs to be down, right? -2 what, guys?
1.5 and 3.5.
All right, so let's try Jaden's. -1.5, 3.5. It's pretty good, right? All right. Do you guys think he found it, or should we move it a little bit to the left or the right? What do you guys think? A little bit to the right? -1.4? I think that's good. I think we got it. All right. It's okay if you don't find it right away. That's why we have the Desmos, so that you can try a few things until you do find it. This is the vertex, so let's go back now. We're going to put it on the paper. It was -1.4, 3.5. Okay, so now we're getting back to what Jesse was saying. He was saying that we need to write an equation. And since it moved 1.4 to the left, it's not x minus 1.4, it's x what? Plus, good. So it's going to be x plus 1.4, and then parentheses squared. And then how do I move it up 3.5? Plus 3.5. And then how do I reflect it? With a negative in front. Now, I don't know if it's going to be like a negative number, like -0.5 or -2. I'm going to leave room in case there's a number there, okay? I'm going to put my negative right there. And we're going to try this in Desmos and see if it works, okay? So go ahead and put that in the roller coaster Desmos. So you have our slides for today. There's a link on slide 6 to the roller coaster. And see if we need to compress it or if we need to stretch it. Okay. So I'm going back into Desmos to try this out. Okay, so here it is in blue. I'm going to change the color so I can see it a little bit better. All right, that's a little bit better. All right, so it looks pretty good. What is wrong about it, though? This side looks really good, right? This side's not perfect. If we wanted to change it a little bit, would it be a vertical compression or a vertical stretch? Yeah, we might want to try to make it a little skinnier so that we can get this side closer. Okay? So let's try a little bit of a stretch.
So how do you make one half of it?
You can't. You really can't make one half of it skinnier. But what we will do is we'll try to pull it in a little tighter. This side will get a little bit closer to the edge of the roller coaster. This side will come in a little bit. So yeah, you can't just change one side of a parabola because it's always symmetric. We could try to shift it over a little bit. Do you guys want to try to shift it over a little bit to the left? We could try shifting it to the left and see if it helps at all. So we could go back to that 1.5. Going back to Jaden's original one, that might actually be better. Do you guys see what we just did? We tried the 1.5 again, and we do have to make it a little bit vertically stretched. So to make it vertically stretched, we need a number that's bigger than 1. I'll start by putting in 2, but you can see that does too much. So we might need something different like 1.5. 1.5 still might be a little bit too much. You guys want to try like 1.4? Okay. So notice, guys, we did change this number here. And now we have a number here as well. And we're going to make a few changes to our paper. Hopefully you guys aren't writing in pen. I was writing in pen. I need to redo it now. So my vertex is actually negative 1.5 now. 1 second while I pause this. All right, so let's go back to our papers now. So we went back to Jaden's original vertex of negative 1.5 comma 3.5. And we found that the A value that was going to both reflect it and stretch it just a little bit was negative 1.4. So our equation in vertex form was y equals negative 1.4 x plus 1.5 squared plus 3.5. All right, remember that's different from the first thing we wrote. We figured it out as we went through it. All right, now guys, this next part is new and it's going to feel very algebra-y. We don't do a lot of algebraic manipulation. We do a lot of graphing in this class. But for this project, we need to be able to compare the two equations, and so we have to do some algebraic manipulation here. So what we're going to do is we're going to take this vertex form equation and we are going to rewrite it in standard form. So the first thing we're going to do is we're going to square x plus 1.5. When you square something, you do not multiply it by 2. What do you multiply it by? Itself. Thanks, Ty. Okay. Are you guys hearing over there? The first thing we're doing is we're squaring x plus 1.5 by multiplying it by itself. So right here, we get x plus 1.5 and times x plus 1.5, and everything else comes down. Okay, now it's been a while, but remember that x times x is not 2x. What does x times x give us? Anybody remember what x times x gives us? Okay, Jaden, stay with us, all right? X times x, when I multiply those together, it gives us x squared. I think some of you knew that. You're like, oh, I should have said it. I knew it. All right, next one. X times 1.5, that's really actually an easy one. It's just 1.5x. And now I'm doing 1.5 times x. So now I'm going to be multiplying this one. And that's actually the same thing I just did. It's another 1.5x. And lastly, 1.5 times 1.5. And for that one, I'll use a calculator. If anybody has a calculator ready, you can go ahead and do that for us. Anybody find us an answer yet? 2.25 is right. Good. Okay. Next. Please make sure you're getting this down. Next, we have to combine like terms inside the parentheses. What are the like terms? Yeah, so we have 1.5x and another 1.5x. Those are the like terms. Do you have a pencil, Tell? They're on the bottom shelf here. Grab one. All right, so I'm going to combine these two together. And that gets me a 3x. All right, so we combine the like terms. Next, we're going to distribute. So we are going to multiply that negative 1.4 times everything in the parentheses. I'll need a calculator again for that. So the first one's not that bad. The first one is going to be negative 1.4x squared. And now I need negative 1.4 times 3x. Anybody have that yet? Negative 1.4 times 3. I get negative 4.2. Anybody else get that? All right, I'm going with it then. And then finally, I need negative 1.4 times 2.25. Anybody already get that answer? Okay, I'm getting negative 3.15. And we are almost done. Does anybody see the like terms that we can combine here? I don't have two terms that have x squared. I don't have two terms that have an x, but I do have two terms that have no x's on them. So I can combine those two. So I'm going to combine those two. All right. So what we just did there was we took the equation in vertex form and we multiplied it out to get the equation in standard form. Okay. Make sure you have the first side done because when we come back from lunch, we're going to work on the second side. Okay? Make sure you have the first side done.